So say we're given an equation with radical expressions like so. Square root of x plus 1 is equal to 1 minus the square root of 2x. So now the first thing we need to do is to square both sides of the equation. There's no point in adding or subtracting terms from either side, since both sides of the equation contain radicals. So it wouldn't be any easier to move the square root of 2x over to the left, for example. So we can just start straight and squaring both sides. Now on the left, the square and the square root are going to cancel out. So we're going to be left with just the radicand, which is x plus 1. But on the right, it's going to look a little bit different, because the radical sign is only on the 2x, and there's this extra term that's being subtracted from it. This is going to look like 1 minus square root of 2x times 1 minus square root of 2x. Basically, when you multiply two binomials, when you multiply a binomial by itself. And then the way we solve this is by foiling. So let's FOIL this on this line down here. So first term is going to be 1. The outer term is going to be minus square root of 2x. The inner term is going to be minus square root of 2x. And then the last term is going to be plus square root of 2x squared. So now simplifying, let's leave the left alone for now. So we get 1. These two terms are like terms, so this can become minus 2 times square root of 2x. And then the last term is square root of 2x squared, which is just 2x. So now that our equation looks like this, we can start adding and subtracting terms. So if we subtract a 1 from each side, these two actually cancel out. So rewriting the equation, we have x is equal to minus 2 times square root of 2x plus 2x. And now it looks like we're going to have to square again, right? Because there's this pesky square root of 2x we're going to need to get rid of. So we want to move everything that's under the radical sign to one side and everything that's not under the radical sign to the other side. So in this case, we want to actually subtract a 2x from both sides. So on the left side, this is just going to become minus x. And on the right, this is going to become square root of 2 minus 2x. Now we could divide both sides by 2 to get rid of this minus 2. Remember, since these two are related by product, as in they're being multiplied together, you can't subtract a negative 2. You can't subtract a 2. You can't add a 2 to each side, rather. But one thing we can do to make our lives a little bit easier is to divide by negative 1. Dividing both sides by negative 1 means that these negative signs on both sides of the equation are going to cancel. So we're left with x is equal to 2 times square root of 2x. And now that we've simplified, we're actually in a position where we can square both sides of the equation again. Because remember, the goal is to have something like x is equal to some sort of number. So having x is equal to 2 times square root of 2x is not good enough. We need to solve completely. So now on the left, x squared is just going to become x squared. And then the square on the right is going to distribute to each term. Because remember, if you have a product of two things, a times b, and you square it, the square is going to distribute to both. So it's going to become a squared times b squared. And in this case, the a is 2 and the b is square root of 2x. So this is going to become 2 squared times square root of 2x. And I can do better. Square root of 2x squared. So simplifying, we get x squared is equal to 4 times 2x, right? Because square root of 2x squared is just going to be the radicand 2x. So simplifying further, we get x squared is equal to 8x. And now, since we want to solve for x, what we should do is move all the terms over to one side and leave 0 on the other side. So we get x squared minus 8x is equal to 0. And now we see if we can factor this out. We'll notice that there's actually an x in common in either of these terms. So we can factor that out of this difference. So we get x, factoring out an x, what's left over here is an x, and what's left over in the second term is an 8. And that's equal to 0. And recall from the zero factor property that if these two are equal to 0, then either one is equal to 0 or the other is equal to 0. Let's put a big or in there so that we know what we're doing. So we have x is equal to 0 or x is equal to 8. So now after all this work, we finally found our two solutions. But we're not quite done, because remember, since we squared at the very, very beginning, all the way up here, that means we might have taken on some extra solutions that don't actually solve the original equation. So what we need to do is we need to check these two into the original equation. So we check by plugging in x equals 0, x equals 0 and x equals 8 into the original equation, which was square root of x plus 1 is equal to 1 minus square root of 2x. So let's do that. Let's do x is equal to 0 first. So we want to check if 0 plus 1 square root is equal to 1 minus 2 square root of 2 times 0. And the way we show, signify this from a notational standpoint is that we put a question mark on top of the equal sign to show that we're just checking. So 0 plus 1, this is going to become the square root of 1, and we want to see if it's equal to 1 minus the square root of 2 times 0, which is 0. Because remember, anything times 0 is always going to be 0. So then we want to check to see if square root of 1 is equal to 1 minus the square root of 0, which is 0. And square root of 1 is 1, and as it turns out, 1 minus 0 is also 1. So this equation, x equals 0, checks out. So awesome! Now we need to check the second one. X is equal to 8. So plugging it into the same equation, we want to see if the square root of 8 plus 1 is equal to 1 minus the square root of 2 times 8. Here we get the square root of 9. We want to check if it's equal to 1 minus the square root of, square root of 16. Square root of 9 we know to be 3. We want to see if that's equal to 1 minus the square root of 16, which is 4. And 1 minus 4 is equal to negative 3, which we know is not equal to the left side, which was 3. So x equals 8 and what's known as an extraneous solution. So it doesn't fit in the original equation. So our final thought should be the solution to the equation is x is equal to 0, right? Because when we checked it, it worked out. And if you want to write an extra note, you can say that x is equal to 8 is an extraneous solution. But it's not really that necessary. This top sentence is good enough.